All right. Good morning, good afternoon, good evening. My name is Jeff Deininger. I'm a solutions engineer at Sumo Logic. And today we're going to walk through application observability and get into a little bit of context about the problem space that we're in here with this conversation, get into a live demo, and have some time for Q&A afterwards. So very briefly, we'll talk about application observability. We'll take a look at some of the capabilities in the Sumo Logic solution that enable effective troubleshooting, including the service map, and then get into trace context as well as logs, and look at sort of the unified experience that Sumo brings to bear on those data sets. And then lastly, we'll get into some global intelligence and the way in which the Sumo Logic service can help make recommendations, which enable you to optimize your Kubernetes deployments and really balance risk versus cost. So I want to start with the problem statement. And really, it all comes down to complexity and dynamism, which means that customers are no longer able to keep up with all of the network of interdependencies that are represented by modern microservice architectures, cloud infrastructure, continuous integration, continuous delivery. It essentially means if you want situational awareness into how well your services are performing, how secure they are, you need to be collecting, of course, the three data sets of metric data, trace data, and log data, but you really need to be collecting them all in a single place. That if you're having to pivot between different tool sets in order to try to manually correlate what's going on, you'll just continue to sort of drown in the data deluge. And so let's talk about an observability solution and what really makes for a good one. So it's not just the notion of getting all of the data into one place and into a place that is itself infinitely scalable. In the case of Sumo Logic, because Sumo Logic is a cloud native SaaS service, you never hit capacity limits, which means that your telemetry ingestion never halts and users are never impeded by poor search performance, poor experience using the system itself. This means that all of the information needed to become aware that issues are happening with your application stack, to actually do a root cause analysis in terms of diagnosing and triaging, and then getting to that root cause by digging below the surface. It's always easy and it's always fast. And part of that is not just the ingestion, but also the analytics that are taking place, that the system is learning your data sets and analyzing them for you. Now, from a collection perspective, of course, Sumo Logic can receive data from anywhere, from content delivery, from identity providers, from any of the public clouds, of course, from any on-premises infrastructure as well. Any element in the application delivery chain is able to generate log data, typically in JSON or syslog, but really any unstructured data you can throw at the Sumo Logic service, and without having to force fit it into a rigid schema, Sumo will make sense of it and let you apply that schema on demand. So I want to talk about the observability solution itself. First, that it was built for observers. Notice there's a common query language that you can use to discover what's going on from a metrics perspective, what's going on from a trace and a span perspective, and then from a log perspective. This enhances the user experience and makes it very simple to onboard new users to Sumo. We also have a number of out-of-the-box dashboards, visualizations, correlations, which let users quickly hit the ground running without having to stop and decide, how do I become a data visualization expert and pick and choose what I want to see and where. All of that you just get out of the box. From an analytics perspective, the ability to enjoy unified search across different data sets is really what streamlines investigations. And this all hinges on Sumo's notion of an entity model, which is bootstrapped by sort of the automated data enrichment that happens at collection time. So not only is Sumo able to ingest metrics, traces, and logs from across your estate, but those data sets are enriched automatically as part of the collection process. And so Sumo Logic's analysis is able to understand what are the entities involved in delivering your apps and services to end users from a Kubernetes perspective, from a cloud perspective, and we'll get into some examples of that. And then lastly, benchmarking and optimization. So Sumo Logic as a multi-tenant SaaS service with thousands of customers understands what optimal infrastructure looks like. We're able to do anonymized original research, looking across the data sets from our customers and see, for instance, that 80% of Kubernetes containers are either under or over provisioned, and then use that information to make recommendations for how you can dial in the configuration for your containers and various workloads. So let's move into a live demo. The demo environment that we're going to see consists of an application we call Sumo Logic Coffee. And this is an application where users can order lattes and various pastries. It includes some AWS DynamoDB from an app perspective. It's, of course, a Kubernetes-based set of microservices that includes some serverless Lambda functions, some EC2 instances, and naturally, it's all built on top of AWS. So from an end user perspective, end users are aware of the front end, right, where they're actually ordering their coffee, they're ordering their cornettos and muffins. And what happens on the back end is those transactions are farmed out to a set of discrete microservices, including a database that contains inventory information and SKUs, a calculator service to tabulate the bill, and then a machine service for our coffee machine, which is actually going to brew our espresso and serve it up to our customers so that orders can be fulfilled. I want you to keep these various service names in mind because we'll see them live here in the demo. All right, so let's pivot over to the demo now. So we have our coffee bar, and I want to start with logs to really demonstrate an investigative workflow with and without trace context. Now, we know that we have this coffee bar application, and so we can simply search for, using wildcards, any of those microservices that include the word coffee in the middle here. And you can see that for the last 60 minutes, we've got about 4,000 different log messages, right? But Sumo Logic makes it easy to navigate through these logs. So you don't obviously have to page through all 161 pages, right? We can filter these down to get just the logs of interest. And so by adding a simple keyword here, I can now take my results down to 113 log messages that have some kind of an error condition. But this is still quite a bit of data to sift through. So Sumo Logic makes it easy to reduce this further using our log reduce capability. This log reduce capability takes those hundreds of messages or thousands of messages and distills them down into a set of a handful of distinct signature patterns. So here we can actually see what are the occurrence rate of different log signatures. I notice that I have a couple of errors here where I'm missing some ingredients. And so Sumo Logic makes it easy to find logs of interest through its query language and through capabilities like log reduce, where the system is analyzing the content of your data for you. But we still don't know of all of the problems that Sumo Logic might have brought to light here, which problem do I need to focus on first? And this is really where trace context comes into play. So I want to take a look at our coffee bar app, and we can start with the service map view. And this service map is automatically generated from transaction trace data that is being collected from Kubernetes, from AWS, right, from all of those infrastructure components. And here I can see I've got my front end where users are actually placing orders. Those orders are coming into the coffee bar where the transactions are farmed out to both the cash desk, that payment system, which is going to tabulate the bill, as well as the coffee machine service, which is going to make the espresso. And right away, I can see some information around transaction volume and whether transactions, errors, and latency levels are within normal range or if they're anomalously high. So this automatic anomaly detection here, I can see when I hover over my coffee machine service, my latency is spiked up to almost half a second, which represents a 7,000% increase over normal. This is something I want to dig into a little further here. So let's click on the coffee service itself. Notice I've got some entity context where I can see for this service and this application, my golden signals around transaction rates, error percentage, and latency. And I can open this in traces. So I want to isolate all of the unique transactions that hit my coffee bar app and this particular microservice. And here they are. I can sort by number of errors, right? And I can get at a glance a duration breakdown for the critical path for each individual user interaction. Notice these root operations. We have a user clicking on pay to kick off the order. I can see all of the services in the critical path, right? Including our API gateway, including a Lambda function for checking suites. And I can see not just the length of time spent at each portion here, but where error conditions are happening. Notice this prepare coffee operation for the machine service. When I click into it, I can now see the HTTP status code of 503 for the post to prepare coffee. And because Sumo Logic is correlating the infrastructure logs with the entities, we can open the logs for just this span ID and see exactly what's happening. So our coffee machine service got a new order, and turns out it was out of water. And so it's unable to fulfill that order. Now at our coffee bar, customers are backing up. The line is out the door because orders are not being fulfilled. And Sumo Logic has highlighted that we can just add some water here to our coffee machine to get unblocked and get the line moving. So it makes it very simple to identify root cause from a service map of our application. And all of this hinges on that entity model again. But what if we didn't want to start with figuring out which specific problem was causing our line to back up out the door? What if we wanted to take a broader view and look at this from an infrastructure perspective? Well, we can do that by looking at all of this is running in AWS, of course. So we can take a look at our AWS Observability Explorer and get a high-level view of all of our infrastructure running in AWS. Here we've got our CRUD operations for our various AWS services like RDB, RDS, DynamoDB, ECS, etc. We can take a look at, again, that golden signal context for transactions, error rates across all of our different services. Here I see I've got 50,000 Lambda errors in the last 24 hours. I can quickly dive in to my prod AWS account, to my US East 2 region, and to the Lambda service, and take a closer look at all of my Lambda functions. Here I can see I've got the top failure, or the top function name that's failing is this get billing info. So I can grab this and just use this as a quick filter on my Lambda focus dashboard to filter the content on all of the charts to just this one function name. So very easy to see where hotspots are happening and how to filter a built-in dashboard to quickly get additional context. The last thing that I want to show is the what we call the root cause explorer. And this is a capability that lets us take all of that signal data from across our enterprise and distill it down into a series of cause and effect relationships that includes some outlier detection, some anomaly detection, to let us understand our leading and lagging indicators. When we see what type of data we're bringing in here, notice we're bringing in a series of AWS and host data, including accounts from all regions. We're bringing in all of our Kubernetes data. We're bringing all of our app services data. And here we can see specific events of interest, indicating not just where anomalies are happening, but where are the big anomalies happening, as indicated by drift and duration. So it's one thing if something is significantly anomalous, say 5,000% over normal, but is just a blip and happens for less than a second. It's another thing if those anomalously high occurrences extend and persist, right, and don't seem to resolve themselves. So this is where these events of interest come into play. And notice again, all of that entity context. So here you've got on the side panel the details about what's happening. You can see this almost 6,000% drift for 10 minutes. And we can look at the entities that are involved here. All right, so now I want to shift gears and talk a little bit about global intelligence. So global intelligence for Kubernetes is something that is an area of value that's unique to Sumo Logic because we're a SaaS service. So we can take, for example, the classic problem of how to provision infrastructure and how to balance cost with risk. Of course, if we over provision our infrastructure, our risk of an outage, and in the case of Kubernetes, container eviction is minimized, but at great expense. On the other hand, if we are under provisioning our infrastructure in order to save money, we have now increased our risk of causing outages, say hitting out of memory errors or containers getting stuck in a crash loop back off state. So how do we strike a balance? How do we know what's right? Well, when Sumo Logic looked across anonymized data from its various tenants and their Kubernetes deployments, we found that this is a significantly hard problem for users to solve. In fact, 80% of containers that were being monitored by Sumo Logic are not optimized for CPU. 86% were not optimized for memory. And when you think about these 4 dials that you've got to set for each container, each pod, right? How much CPU and memory to allocate? What are the requests and limits to specify? It becomes really, really impossible to do this if you're relying on kind of trial and error. And so what Sumo Logic is able to offer are some specific recommendations that let you strike a balance between cost and risk, where you can say, take a pod that is over provisioned and reduce costs for the same risk level. You can take another pod that's under provisioned and you can increase resources to reduce risk without exploding your cost. So with Sumo Logic's global intelligence service, and we have this for Kubernetes, we have this for Nginx, for all major infrastructure, we're looking at how to strike that right balance. These out-of-the-box dashboards provide a summary of your allocation and what risk percentage that equates to. And this lets you sort of continually improve not just how your service is delivered to end users, but how much you're paying for the infrastructure that's powering your services as well. So with that, I want to make sure we have some time for questions. I've got my colleague Rob Plon here, who has been looking at the Q&A, and let's get into some questions.
Nothing in the Q&A at the moment, Jeff.
Okay. So if you have questions, feel free to throw them in the Q&A. And while we're waiting, Rob, I'll just ask you, what's the most common question that you're hearing from customers around, let's say, deployment?
Yeah, I was going to say that the most common questions I get first is, how do you do this? How do you get this data, flowing, into the platform? And automation is kind of the name of the game these days, right? DevOps and how can I just do this automatically, programmatically? And so Sumo Logic has a variety of automation techniques that you can employ. So for example, for Kubernetes, that's as simple as a Helm chart install. For things like AWS observability, you can either use something like Control Tower. We have cloud formation templates so that you can automatically discover everything that's there. You don't have to point it at anything more than an account, and it can go through and inventory everything. And then we also have our own Terraform provider, and we have heavily used Terraform internally. So those are just some examples of different ways that you can automate the ingest of your data.
Yep, and of course, for our Azure users out there, we'll provide Azure Resource Manager templates and similar set of automation tools to collect data via event hubs using Azure functions. Yeah, good question. So then, how are we doing on the Q&A? Anything coming in?
No questions so far.
So one thing I want to underscore is this notion of trace context and context propagation. I think this is a pretty crucial distinction here between, you've got all of your logs, but how do you get to the logs that you want when you need them, right? When you're in a troubleshooting scenario. And this is really where the magic of those traces and that context comes into play. So if you're able to isolate individual user transactions represented by a trace ID, and then break that down into the individual span IDs for the components of those transactions, you're really able to have Sumo build out for you a visualization of that critical path in order to see, when I have latency, where's the bottleneck? Where's the time being spent? When I've got reliability issues or availability issues, what are the pieces of my stack that are generating those errors? And then pivoting off of the Sumo entity model down into just the log messages for just those entities that are relevant to that portion of the investigation you're doing. It's really powerful and makes for a pretty straightforward workflow that lets end users get their services back up and running as quickly as possible.
Yep, context is king, I always say. I think too, what we find is that in most of the companies that I talk to, you've got a lot of different people in the audience. Some are focused on the infrastructure, whether that's on-prem or cloud. Others are focused on developing things, and others are focused on CI/CD and how to get it into the environment. Some people are maybe doing the more SRE role. So there's a lot of different consumers of the data, and I think that's where this context really comes into play too, is the ability to sort of pivot from the point that's most accessible to you or most important. So if you're looking at supporting the cloud infrastructure underneath a Kubernetes deployment, for example, you might be wanting to look across all of your clusters and all of your nodes and what's happening. But then when you see a particular pod or a particular deployment or namespace that's having trouble, it's nice to be able to quickly pivot in and see, well, what's deployed there and who's using that and what's happening. And in the reverse, if you're a team that's responsible for a specific set of services that have been deployed into Kubernetes, you probably don't really know or even care which node or which cluster it's running on. But when you see a problem with your deployment, to be able to start there and see your deployment, your things, and then see a problem and be able to see, okay, well, what is the node or the underlying cluster that this is related to? So maybe I know what team to call or something like that. So context is important depending on which hat you're wearing as well.
Yep, absolutely.
So still no questions here, Jeff. So we can probably move on.
Yeah, well, we're basically at the bottom of the hour, so I'll thank everyone for their attendance and give everyone 3 minutes back in their day. I will say before we break, though, if you want to learn more about Sumo Logic, we have a series of blog content that's great to dig into. We have our public Slack channel, our Sumo Dojo, where you can engage with us, ask questions. And of course, if you want to get your hands on Sumo Logic itself, you can start up a free trial and use the perpetually free tier of the service. So start bringing in your logs, and yeah, we'll see you out there. Thanks a lot, everybody.